So let us discuss the low copper conventional amalgam alloys. So when you triturate the alloy particles and the mercury particles, what you see is the silver and the tin that is present in the outer portion of particle. It gets dissolved into the mercury. The mercury diffuses into the alloy particles and start reacting with the silver and tin within, forming crystals of, it forms the crystal of silver mercury, that is gamma 1, and tin mercury, that is gamma 2. Remember, the silver tin compound, that is the unreacted powder, that is the unreacted alloy powder, it is known as a gamma phase. So remember, the silver mercury compound is known as a gamma 1 phase, and the tin mercury, it is known as a gamma 2 phase. So remember, the property of the hardened amalgam, it will depend upon the proportion of the reaction phase. If more unconsumed gamma phase is present, that means the stronger will be the amalgam. That is what you have to remember for your exam. The stronger phase is the gamma phase. So which one is the strongest phase? It is the gamma phase. Which one is the weakest component? It is the gamma 2 component. So what is gamma 2? It is SN8 Hg. SN8 Hg. So this is least stable to corrosion. Now let us discuss the microstructure of it. The set amalgam, it will consist of unreacted particles of gamma phase, that is surrounded by matrix product of the gamma 1 and gamma 2. So the property of the hardened amalgam, it will depend upon the proportion of each of the reaction phase. So if a more unconsumed Ag3SN, that is gamma phase, is present, it means the stronger will be the amalgam. So this was all about the low copper conventional alloys. So gamma phase, it is Ag3SN, that is the unreacted alloy. It is the strongest and corrodes the least. And it forms 30% of volume of set amalgam. That is what you have to remember for your exam point of view. The gamma 1, it is Ag2Hg3. It forms matrix for unreacted alloy and it is the second strongest phase. It consists of 60% of the volume. The gamma 2 phase, that is SN8Hg, it is the weakest and softest phase. It corrodes faster and the corrosion will yield mercury, which reacts with more gamma and it forms 10% of volume. The volume decreases with the time due to the corrosion. Now let us discuss about the high copper alloys. The high copper alloy, that means they contain copper between 13 to 30% of the copper. So the high copper, they will have copper content between 13 to 30%. Remember, the majority of amalgam restoration placed are of high copper. Why they are preferred? They are preferred because of their improved mechanical properties, their resistance to corrosion, and better marginal integrity. Now, what are the types of high copper? There are two types. One is the admixed alloy particle and second is the single composition alloy. So remember, the admixed alloy powder, it was first originated in 1963. So it contains 2 parts of weight of conventional composition of lathe cut particles plus 1 part by weight of sphere of silver copper eutectic alloy. Now a eutectic alloy is one in which the components that will exhibit complete liquid solubility but a limited solid solubility. So remember, the amalgam that is made from the mixed powder, it will be stronger than that is made from the lathe cut low copper powder. Now the admixed alloy powder, it can be of 2 types. It can be either regular or traditional admixed alloy or unicomposition admixed alloy. So remember, the admixed alloy, they usually contain 30 to 55% spherical copper alloy. The total copper content will range from 9 to 20%. Now let us discuss the reaction. So the silver, that is silver from the silver copper eutectic alloy particles, and both the silver and tin from the silver tin alloy particles enter the mercury. So the tin, it dissolves in the mercury, reacts with the copper of the silver copper particles and form what is the eta phase. That is the eta phase. That is, eta phase is, remember, so this eta crystal, it will form around the unreacted silver copper alloy. At the same time, you will see there will be formation of gamma 1 phase. As you know, in the low copper alloy, the gamma 1 will surround everything, forming the matrix. The gamma 2, that is also formed at the same time, but later it is replaced by the eta phase. So in admixed alloy, you will see the gamma 2 phase is greatly reduced. So the gamma 2 will be reduced and later replaced by the eta phase. So in the set structure, you will see the eta particles, they are present as halo surrounding the silver copper alloy particles. So the final set material that will consist of core particles of unreacted silver tin, that is the gamma phase, and unreacted silver copper that is surrounded by a halo of the eta phase embedded in the matrix of the gamma 1 phase. So this one is the matrix. Next comes the single composition alloys that are the unicomposition. Why they are known as unicomposition? Because it contains particle of same composition. Usually spherical single composition alloys they are used. So these are the high copper amalgam alloys. So unlike in the admixed alloy powder, each particle of the alloy will have same composition. That is why they are known as a unicomposition. Now what you will see, the particles here will have same composition. The silver, tin and copper, it will exist in various phases within the particle. The final composition amalgam that will consist of particle of unreacted gamma phase that is surrounded by a mesh of rod of eta phase embedded in matrix of gamma 1 phase. So this was about the single unicomposition alloys. So these are their composition that you have to remember.